I'm Lucy.
I'm Callie.
I'm gonna teach you about the product rule.
And I'm going to teach you about the chain rule.
I hope you enjoy.
Okay guys, so today we're going to be talking about the product rule, which is a technique used when taking the derivative of a function containing multiplied terms. Alright, next we are going to go through the general definition of the product rule. And so if we have a function f of x and it equals u times v, then taking the derivative of that, we have to use the product rule. And so when taking f prime of x, it equals u prime times v plus v prime times u. Now we're going to be doing an example, and our function for this example is f of x equals x squared minus 1 times x plus 5. So when breaking this down, we need to break into u and v. So doing derivatives separate, u equals x squared minus 1 and u prime equals 2x. For v, it equals x plus 5 and v prime equals 1. Now we are going to take the derivative. So f prime of x equals u prime, 2 of x, times v, x plus 5, plus v prime, 1 times u, x squared minus 1. Multiplying those out, we get 2x squared plus 10x plus x squared minus 1. And simplifying that out, we get 3x squared plus 10x minus 1. And into our next example, our function is x squared times cosine of x. So breaking these back into u and v, our u function is x squared and the derivative of u is 2x. For v, it's cosine x, and v prime is negative sine x. Now taking the derivative of f of x, we have u prime, 2x times v, cosine of x, plus v prime, negative sine x, times u, x squared. Simplifying this out, we get 2x cosine x plus, minus x squared sine x.
Alright, now that we've learned the product rule, it's time to learn the chain rule. So the purpose of the chain rule is to find the derivative of a function that is a composition of two or more functions. An easy way to see how the chain rule works is to look at the general function. F prime of x equals f prime of g of x times g prime of x. So we can see here that we take the derivative of the outside function, keep the inside function, and multiply it by the derivative of the inside function. So let's start by taking a look at an example. This question asks to find the derivative of f of x equals 2x plus 4 squared. So I want to look at it through the lens of f of x and g of x. So the g of x part, or the inside function, is 2x plus 4, and the outside function, or the f of x part, is the squared part. So let's start by color coding so that it's easier to look at. So we have the 2x plus 4 squared equation. Now I want you to look at it through pink and green. So f of x is pink, and g of x is green. So now if we take the derivative of the f of x portion, we have 2 times the inside function, which is green, so we keep it the same. And then we multiply by the derivative of the inside, which is 2. And then if we simplify that, we get 4 times 2x plus 4. And if we simplify even further, we get 8x plus 16. Alright, so let's get into another example. This example is also asking us to find the derivative of a function, but this one is a little more complex. So we're going to break this one into parts and color code it just like we did the last one. So we're going to take 2 parentheses and write in the inside function 3x squared plus 8x plus 7, and then this is to the power of 4. And now, because we're having another area, we're going to add this in a different color. plus 6 parentheses 4x to the 5th minus 2x cubed, and then back in with the red, squared. So now as we take the derivative of this, we're going to take the derivative of the outside. So 4 times 2 is 8, and then we subtract 1 to make it 3. And now we leave the inside, just like we did in example 1. And now we multiply by the derivative of the inside, which is 6x plus 8. So now that's our first part of the function. And now we're going to keep this addition here and add and do the exact same thing to this part of the equation. So 6 times 2 is 12 times the inside staying the same, and then we multiply by the derivative of the inside, which is 20x to the 4th minus 6x squared. And because that's super long, we can just say that's the answer. We hope you find this helpful.
Happy studying!